Hey little guy, you ready to cut your panels to size? Not so fast. First, we need to take a few measurements.
Now this is a really important part in the process when building with a plan. At a certain point, you have to start letting the parts that you've already built dictate the size of the parts that come down the line. You see right now with these panels, here's one of my frames. Now if I put this together and measure, I may find that the distance between these things, just because of natural cumulative error, might not be exactly what's in the plan. So you want to account for that. So instead of at this point just saying, okay, the plan calls for 32 3/4, I'm going to cut mine to 32 3/4. What I'm going to do is pre-assemble this frame, lock it down as if it were in a clamped position, the way it's going to be when it's finally assembled, and take some measurements and figure out exactly what those panels, as far as length and width are concerned, what they should be. So the first step in doing this, we have a middle piece here that we don't know exactly where that's supposed to go. We need to put reference marks so we know exactly where the center mark is, and we can put that rail in a proper position. So to do that, I grab one of my front pieces and I mark it. It's using my adjustable square here. Go from each side, and that'll make sure whatever I put on the board is perfectly centered. Okay, so center mark here. I'm going to do the same thing on the right one. And then I want to take my middle rail and mark the center point of the middle rail across its width. And all we'll need to do from that point on is line up our pencil marks. Okay, so let's assemble the frame. Okay, so I have a clamp in place, and that's going to kind of keep everything together, and I can get accurate measurements that way. Now I use my little adjustable square to get the actual depth of our grooves here, which happens to be a little bit more than the plan called for. I must have gotten just a little aggressive on that. So it's just a little bit more than 3/8. So what I'm going to do is lock that down, and I'm going to use the pencil and the square to transfer that mark to the top of the boards. Okay, one on each side. And then also, I'm going to put them on the middle, one on the bottom, and then we'll do the top as well for good measure, because we want to make sure we have all of the dimensions measured here. Okay, so all of the marks are in place, and now we can take an actual measurement. Now for instance, the length here, as far as the plan is concerned, it calls for 32 3/4 of an inch. And I'm sure we're pretty close, but you never know. Sometimes you may have done something a little bit differently. You don't want to go cutting those panels blind. So what I'm looking at here is just a hair over 32 3/4. So we're pretty close. In fact, I think I can cut the panels at 32 3/4 and call it a day. It's close enough. But the real dimension that we should really be focused on is the width, because the wood is going to expand across the grain, not with the grain. And quarter sawn white oak is pretty stable. It doesn't expand a whole lot across the grain, but it still will have some expansion. So we want to be able to plan for that. So now I'm just going to measure from the other two lines that I created, and that gives me roughly 5 3/4. Now the plan calls for a panel that would be 5, I believe it's 5/8. So we have a little bit of a discrepancy there from the plan to what we have in reality, but that's fine. We needed to know that. And interestingly enough, that happens to work out in my favor really nicely, because if I do cut this board to 4 5/8, that gives me an 1/8 of an inch breathing room, which would be a 1/16 above and a 1/16 below this panel, so that this can expand and contract with the seasons. And I'm going to double check myself here. I don't trust just one measurement. Even though my pencil marks have this center board lined up where it should be, just to be safe, I'm going to measure at the top too and confirm that measurement. Okay, and 5 3/4 looks good. So I'm going to, even though the space is 5 3/4, I'm going to cut my panels to 5 5/8. And keep in mind, if you're using plywood, you don't really have to worry about it so much. If it's 5 3/4, cut your panel to 5 3/4.
So now I can cut the panels. I'll start by ripping them to width at the table saw. And even though the upper side panels are actually made from 4/4 stock, this is still a good time to cut them to size. I then cut the panels to their final length at the chop saw.
Now the upper side panel, even though it's the same dimensions as the lower side panel, it's 3/4 of an inch thick. And the reason they do this is because this is where the handle is going to be attached, and they want some meat in there to be able to do that. And not only that, the inner tray that goes on the inside has to sit on a little ledge, and that ledge is placed in a groove that we put on this board. So we need something more substantial there. So what we need to do now is trim around the outside, put a rabbet on all 4 sides that will leave us with a little tongue that goes perfectly into our rail pieces. What's different about this than the other pieces is before we had a centered tongue in the middle and we removed material on both the top and the bottom. For this panel, we're only going to remove material on one side, and that will leave us with sort of an offset tongue. What that's going to do is it's going to make it look exactly like all the other pieces from the outside. You'll have that little bit of a reveal, and the panel will look pretty good. From the inside, it's going to sit proud of the surface. And it'll all make sense as we go through it later on, but that's where we're going to be able to cut our groove in there, which will allow the piece to, the tray to sit on top of that. But all you need to know for now is we need to create a tongue, but it's going to be offset to one side. So I'm using the same setup that we've done in the past with the auxiliary fence and a dado blade. The blade is buried again. What I'm going to do is cut across the grain using the miter gauge, and then the long cuts I'll be able to do without the miter gauge. And just like when you do raised panel doors, there's a certain order. You know, do you cut the across the grain first? Do you cut with the grain first? Well, since cutting across the grain has a tendency to tear out more than cutting with the grain, I'm going to cut those first, because at the end of each one of these cuts, I get to turn it 90 degrees and remove that material that just tore out. Okay, so it's a safer bet if you do it that way. And the only other thing you want to know is you want to have, when you're making this cut, you want to have the face that you want to stick out, the side that you want visible on the outside. You want to make sure that's up, because we're going to be removing the material from the inside face of the board.
I create the rabbet on the ends first. Then I make the cuts with the grain. Notice anything wrong here? I have a clamp that's just a bit too low at the end. It wasn't a problem on the cross cut, but for this rip, it's definitely going to be in the way. Once I realize this, I instinctively hold the workpiece firmly against the fence and shut the saw off with my knee. Some may feel it would have been better to pull the piece away from the fence while pulling the piece back toward me, but from my experience, whenever you confront a dangerous situation at the saw, it's best to hold the piece firmly in position and wait for the saw to stop. Trying to move the workpiece while in the heat of the moment could very well result in the exact disaster you are trying to prevent.
Now while I have the dado in the table saw, I'm going to go ahead and create a groove down the center that's going to hold that 3/4 inch ledger strip to support the tray. Now if you look at the pictures in the plan, you'll notice that the inside edge of these upper panels is actually chamfered, and it gives it kind of a nice effect. The way it is now is okay, so this is completely optional, but I think it really does add just a nice visual look to the inside, softens it up a little bit. So what I have here is the blade is beveled to 45 degrees, and it's just barely coming out of the top of the table saw surface, because all we really want to do is clean off some of that extra material there and cut it at a 45. So what I've got is my miter gauge here. This is one of my extra miter gauges set up on the right side slot. And I've got my fence in place and a little reference block that tells me exactly where it needs to be. Okay, and then I can push it into the blade and get that 45-degree cut. For the long edges, I'm just going to bring the fence over, set it up, probably by eye, just make sure it looks okay, and give it a pass on each side. Now before I do any assembly, I'm going to sand all of my panels down to 180 grit. It's just a heck of a lot easier to do it now than later when we've got a frame wrapped around it. So most of you are probably wondering, should I also be pre-finishing these panels? Well, you know, it depends. It's up to you, really. But if you're going to stain it, I would say yes, because you don't really want to take any chances of that board shrinking down and exposing an unstained portion of the panel. So if you do that, just give it a coat of stain. And usually, I would give it one coat of finish and then do the assembly, because you don't really want the center panel to be that far off from the rest of the piece. So if it just has stain and one coat, then when you assemble everything, you could refinish the entire panel and frame at the same time, and the center panel is only one coat ahead of the rest of the piece, so there won't be much of a difference in the sheen or the look of the finish. But for me, you know, these are relatively small panels. I don't think they're going to move that much, and I'm not staining this piece, so I'm not going to do any pre-finishing to the panels themselves. I may pre-finish the sub-assemblies when it's the full frame and panel is glued together and already sanded. That I may do, but at least at this point, I'm not going to do anything special with the panels. All right, and finally, we can glue up one of our side panels. Okay, so during my dry assemblies, I realized that with 3 separate rails like this, it makes it really difficult to get all those pieces in position perfectly while you're racing the clock for the glue drying. So I've decided to start with the middle rail. So we put a little glue in the grooves here. Now just line up my pencil marks. Same thing on this side. Now I could add a little clamping pressure. Don't hammer it home, just snug it up so that it doesn't have a tendency to move anymore. Now I'm going to add my panel. This guy floats, so no glue. Might be a tight fit. If it is, just loosen this clamp up a little bit, and that should give you enough wiggle room to squeeze that extra rail in there. Now your fingers are your best friends at this point, because they very quickly, without even looking at it, let you know if this is perfectly flush at the top. And finally, the big panel. So now the great thing about this is with these two clamped in position already, I can hammer up at the top and it doesn't really move these. And that was the problem I was having in the dry assembly, is I couldn't hit one thing without it moving something else unintentionally. Okay, give them all a good turn. And now I get to go eat dinner.
After dinner, I assembled the larger frame and panels in exactly the same way as the small ones.
Now I'd like to show you just one more option on how you can make this tongue and groove joint, and that's actually with the router table and a special tongue and groove set. Now this particular bit, this is one that I got from Eagle America, and it comes with multiple bearing sizes, multiple shims. The idea is you create a stack, okay, and then you screw this, this nut on at the end. And the concept here is to make sure that the space between these two pieces is exactly the same as the space that one of these little discs here, one of these bits would create. So I use the top bit here to create this groove, like so. The bottom bit just kind of hangs out below the surface of the table. Once I have my groove, then I can go back and cut the tongue. And the tongue is done by raising the bit up a little bit, okay? And you see I remove the material from above and below the tongue. And when it's all said and done, you're very, very quickly left with a pretty accurate joint, like so. Now this one is a little bit loose and I need to tweak my setup a little bit, but you can get the idea. And this works very quickly. You get both the tongues and the grooves done in no time flat. The only thing I will show you that you need to do that's a little bit different here is when you're trying to create these tongues, running this over the router table is pretty dangerous. So I do recommend having something like a coping sled on hand. You can make these yourself or you could buy these pre-made. This particular one is from Eagle America also. Clamp this guy in like so, and now you've got something safe that you can actually run across the router table and get this end grain routed nice, and you sort of have this plastic material behind it that supports the fibers and stops them from tearing out as well, which is going to be critical for this cut. So with all the panels glued up, I can now do another dry assembly, and this time I'm going to measure for the bottom panel. That panel is going to go into a 3/8 of an inch deep groove all the way around, so I can actually just measure right from the workpiece itself, and once again, disregard what's in the plan because things may be different on the actual piece. So I just give myself a little 3/8 of an inch on this side, and then give myself about 3/8 on this side, maybe just slightly less. And whatever that number is the length of my panel. And I'm going to do the same thing across this way for the width.
I cut the 1/2 inch bottom panel to width on the table saw. And the Festool MFT is perfect for cutting it to length.
All right, so we are giving this dado blade a serious workout with this project. We need to go back to the dado blade to create the groove that goes all the way around for the back panel.
Creating the grooves on the side pieces is going to be a little bit unusual. Remember, the upper side panel sticks out by about 1/4 of an inch, so I need to tape on a piece of 1/4 inch thick scrap as a shim to keep the piece nice and flat on the table. I then raise the dado stack an extra 1/4 of an inch to compensate for the shim.
So now each side panel gets this little ledger strip. It's going to go into the groove we cut earlier, and just a little bit of glue and some clamping should take care of that. And again, this is to support the tray that sits on the top of the box.
Nothing tricky here, just glue and clamping pressure.
Now you might be wondering why I'm wearing a SpongeBob birthday hat, but if you look closely, you'll see it's actually a dunce cap. I screwed up, and as my punishment, I'm going to wear this for the rest of the day. If you look closely here, we've got a little hairline gap, and the reason for this gap is either that the tongue was just slightly too long or that the groove itself wasn't cut deep enough in that area. The reason I'm wearing my dunce cap is because that was something I really should have caught during the dry assembly, and I didn't. So now we're forced to fix it or leave it alone, depending on your preference. Now you could just put a filler in there, but as we know, fillers don't always match up that great, and over time they can kind of work their way out. And the other thing is when you use a filler, it tends to get into the grain around the area that you're trying to fix and sort of expanding the eyesore a little bit because it creates a little bit of a finishing issue. And especially with oak, that stuff will basically get into all the little open pores and grain, and it's just not a pretty sight. So what I'm going to do is use wood to repair this. It's a small enough area, it's kind of out of the way, so it doesn't have to be absolutely perfect, but a wood repair is going to give us the most visually appealing repair here. So what I have is a very thin piece of the white oak. This is just a scrap that I had laying around from one of the cutoffs. Thin enough to fit inside this little slot here. And with a little bit of glue, I'm just going to wiggle it all the way down and let it dry. And once the glue sets up, that's just regular CA glue and a quick set activator. You can just break it off. Now I'm just going to, whatever way I can, cut away some of this excess material here. I've got this little razor saw, which is pretty sweet. If you guys don't have one of these, it's just a super, super fine tooth saw. That works great for an application like this where we need to be really gentle. Sorry that we could lose a little more there. And then I could use a chisel to get rid of the rest of this stuff. Okay, we could probably switch to a sander at this point. So that's a pretty reasonable repair. I'm definitely happy with the way that turned out. I think I forgive myself.